here would lick this battery? Okay, well for the rest of you, why not? Do you think it's dangerous? Well actually, in the 2014 video, licking a 9-volt battery with SparkFun, Sean Himmel shows us that it's actually perfectly safe to lick a 9-volt battery. And the reason I bring this up is because electricity is everywhere. It surrounds us, it defines how we live. But how many of us actually know what electricity is? As an electrical engineering major and being a member of the IEEE, which stands for Institute of Electric and Electronic Engineers, I have been able to learn a lot about electricity. And I'm going to use my knowledge and my experience to make sure you all have a basic understanding of electricity. I'm going to teach you all about the main 3 parts of electricity and the relationship they have with each other. So I'm going to talk about voltage, current, and resistance. In SparkFun's 2013 article, C. Taylor claims that these 3 are the 3 main building blocks required to utilize and manipulate electricity. And I'm going to start with voltage. So the unit for voltage is a volt, and it is represented with the symbol of a capital V. And as M.S. Naidu says in his 2000 article, Introduction to Electrical Engineering, voltage is the force that tends to reduce an electrical current in a circuit. And I know this might not make sense yet, but there's a really good analogy to use with electricity, and that analogy is water. So here we have a pipe full of water, and in this pipe you can see that the water on the top is going to cause the water to flow through the pipe and come out of the bottom. This water at the top would be considered the voltage of the circuit when you're thinking of it in terms of water. And if that doesn't make sense, we can also think of voltage in terms of a water pump in the system. So the water pump will cause the water to flow through the pipe over and over, just like how a battery would cause electricity to flow through the circuit. And then it is also important to note that the water pump has a low pressure side and a high pressure side, just like the battery. This can also define voltage as the potential difference between 2 points, how there's a high and a low. That's what creates the flow. And now before I go on, I want to talk about how R. Nave mentioned in his Hyperphysics article, DC Current Water Analogy, that this analogy is only valid up to a certain point. Once you start talking about more complicated things, it kind of falls apart, but for our case, it will be valid throughout this presentation. And now we have current. The unit for current is an ampere, or amp for short, and is represented by a capital I. And current is the flow of electricity through a circuit. And in terms of water, it is the speed of which it flows. So here we have 2 pipes or circuits with the same amount of voltage, and you can tell that because they have the same water level. But as you notice, the right pipe is smaller, which will allow less water to flow through. This means that the current on the left pipe is greater than the current on the right pipe. And now before I go on, I have one fun fact about current. Current is the one part of electricity that can kill you. This is a chart from Paul Giovannazzo's 1987 article, The Fatal Current, that shows the range of current and the effect it has on the body. So you see, it doesn't take a lot of amps to actually kill someone. But luckily, our bodies are able to resist that current most of the time. And just so you know, licking this battery, the current would be around in the mild sensation area. So you definitely feel it, but it will not kill you. So go ahead and try it at home. Now on to the simplest component, resistance. The unit for resistance is an ohm, and it is written with the Greek symbol omega, and it is represented with a capital R. And just like it kind of says it in the name, electrical resistance or resistance is the electrical resistance of a circuit. And in terms of water, it is basically the shape of the water pipe. Here we have two pipes, or in another case, it would be like part of the circuit, like the wire. And we can see that the top pipe has, the way it's built, it allows a lot of water to flow through, which means it has a less resistance. And the bottom pipe, which is built to restrict water flow, has a greater resistance. And this is the same in terms of electricity. And we give resistance into a circuit by inserting a resistor, which are these four things on the page. And I have a couple here in front of me. As you can see, they're really small and they're pretty malleable. You just bend them and just put them in the circuit wherever you'd like. And resistors are just electrical components that are designed to input a certain amount of resistance into a circuit. And in circuit diagrams, the resistor is represented by the squiggly line. And this is shown in Sarma's 2001 book, Intro to Electrical Engineering. Now, as you guys might be able to tell, all these voltage, current, and resistance, they're all tightly related to each other. As we can see in this picture, if you increase the ohms or the resistance of a water pipe, it will allow less water or electricity to flow through the pipe. But if you increase the amount of voltage, it will push the amp through, which will make a greater current. So they're all tightly related, and this relationship is described as Ohm's law, which is just an equation where V is voltage, I is current, and R is resistance. And this this equation is probably one of the most fundamental equations in electrical engineering, and it helps us create and manipulate electricity in many ways. So by describing to you all the different parts of electricity and how they are very similar to water in a pipe, I hope you will all have a basic understanding of electricity, so that the next time someone asks you to look at a battery, you will know why you're saying no, not just to say no. Thank you.